my name is Jesse. Today I'll be talking about object-oriented programming, also known as OOP, with applications to game development. A little bit about me. My name is Jesse, like I said. I'm in 8th grade. I go to International Community School, and I'm actually from Washington. I'm not from California, so yeah.
We could tell.
So, looking at the diagram above, we have our centric OOP, which is obviously object-oriented programming, and we have 6 main concepts that sprout from our originator. We have the class, the object, encapsulation, polymorphism, inheritance, and abstraction. But for time reasons, we aren't going to be going over abstraction or encapsulation, as those go a little bit too in-depth for this presentation time. So what is object-oriented programming? Well, object-oriented programming is a way of structuring programs by grouping related properties and behaviors into individual objects. But what specifically is an object? Like, everything around us is an object, isn't it? And this is very true. If we look at the picture above, we have many objects, from a soccer ball to, is that a turkey leg? I can't see from here. A block of cheese and whatnot. Objects are at the center of object-oriented programming, if you couldn't already tell from the name. You can think of objects as components from a computer, such as the motherboard, the RAM, a CPU, a GPU, and on. Every object is a job, and without an object, the system wouldn't properly function. The object is an entity that has a state and a behavior associated with it. And like I said before, an object could be anything from an integer, a string, or a float. Now, our second main concept is classes in OOP. If we look at the picture above, we have a picture of our car class. This isn't the best picture to describe classes, but yeah. Classes are a functional way to store and manage data. So you can think of me. I could technically be, I could be a class. The car is a class and whatnot. And classes hold a function, which are statements or data inside of them. And you can see below. I don't know what those are called. I can't speak today. But what exactly?
Properties.
Yeah, there we go. Properties. But what exactly are functions? Well, if you look at the picture above, we have a picture of a car, our factory, and our finished car. That's all beautifully, sparkly, and colored. Well, we have our starter class, but then inside of the factory is where our function comes in. This is where it takes this is where we give it a parameter, we give it data, and it does, I don't know what the word is, it does something to the data, and then it gives us an output in the end, which is our object. This is what a function does. Functions are segments of statements that return a specific task. And it's very common to put common and repeated tasks together, which is a function. Now, where can classes and functions be used, you may be asking? Well, sorry, that's such bad wording. From let's say me and my father, we have a relationship between us, me and my dad over there. We have similar, he passes on genetics on to me. For example, I am Korean, and whatnot. We have a lot of similar things, especially from this picture above. I inherit a lot of things from my parents. Hence is where the word inheritance comes from. So we can think of it as where our parent class and our child class, where our parent passes on, or the child inherits qualities from our parent. It can be anything from me being Korean, or my hair color, and many other things on. There's code on the side as well for anyone who actually knows what it is. But something that is different, that it's still the same name, our age, but I don't think me and my dad have the same age. That would be kind of weird. That is what polymorphism is. It's where you have the same function name, but it's completely different. So in this example above, we have a picture of a tiger, a monkey, and a cow. Our parent class is our animal, and our child class who inherit our function sound is our tiger, our monkey, and our cow. But all of these animals do not make the same sound, and this is what polymorphism is. This is where these child classes do not have the same function, or like the internal, or like they don't have the same type or same sound in this case as the others, or the parent class as well. Sorry, my mouth is kind of dry.
You can take your time.
How do I pause this? Before I start, thanks to Elliot. This is actually his video from last year because my video got corrupted on the way here. So yeah, but just imagine that the top row is like red aliens, and that they take 2 hits. Just for my example. And thanks again, Elliot. So yeah. As you can see from the video, it's just your typical alien invasion. But where does object-oriented programming apply to this alien invasion game? Well, we can start from the basics from what we see. We have our alien class, and as I said before, just imagine that the top row, the very top row, takes 2 hits. So, and this is for later on. We have our class, as we talked about, and this is where we store our data. Let's see how he moves around, and as you can see, our aliens start to move around, and this is what each of the aliens do, as you can see. Epic music, I know. And this is where we are able to manage and store our data. But just imagine that the top row is red, then they're inheriting the same values for how they move and how they work, but using polymorphism, their color and their hit and the amount of hits that they take are completely different. Yeah, the applications to game development. What have I learned? This is a bad picture. What have I learned? It's literally just the same thing as before. What have I learned? Object-oriented programming and its applications, so anywhere from being able to apply how these things work in games, have what I have really learned. So what's next for this? Using AI hand tracking technology, we might be able to, let's say, move our hand to the left, and then our ship might go to the left, or move our hand to the right, and then it might be able to go to the right. Yeah, thank you for listening to my presentation.
Object-oriented programming, it's not my favorite type of programming, but for video games, it's actually the best because you have an inherited system. And for the parents here who don't understand still object-oriented programming is, think of it like this. You're not a mechanic, but you buy a car. When you press the key, put the key in the car and you turn it, you expect it to start. You don't understand how engine works, you don't understand carburetors, you don't understand gear shifting, but you know there's a button you press, there's a window wipers up and down, you know how to use it. Object-oriented programming is kind of like the paradigm that enables for people to not understand how something works deeply, but still be able to use the properties of it. So it's very, very important. Any questions from the audience? Objects. Objects everywhere. One funny thing when I was first learning object-oriented programming was learning about abstractions. Abstractions, right? So can you go back a few slides? To your animal sound slide?
Yes, this one.
So for example, what I mean is, if I say, make a tiger, create a tiger, you kind of have an idea. Orange, black stripes, roar. if I say make an animal, what does that mean? What do you think of? You can't make just an animal. You have no idea. So animal is an abstract class, right? It's like, it's an idea. So objects is all about the very base abstract idea and then creating real concrete things, concrete objects from them. So very powerful programming paradigm. You will all learn it if you take computer science. So you said, Jesse, you're in 8th grade?
Yeah, I'm in 8th grade.
Dude, why do you act like you're so much older? I'm extremely impressed. Object-oriented programming, recursion, HTML, CSS, game development, like, that's insane that you guys are doing all this. And that, I know Sam is like kind of overseeing the program, but he doesn't know details about all these things. So the fact that you guys did it on your own, and like how Elliot was like, nobody had anything online for me to look at, so I had to think of it all on my own. That's engineering right there. That's really engineering. Like build a bridge. How heavy? How big? You know, how long? And that's what you guys did. So I don't know. It just seems really cool to me. I had no idea how to do any of this stuff until I was 27. So super cool. What do you want to build with object-oriented programming other than games? Have you thought about that?
So I kind of want to go into like machine learning more, like specifically. I think that's what Philip did. Kind of. I kind of forget. Kind of just want to go where like my dad kind of is right now into software engineering. No, following my parents.
Where's Jesse's dad? He's really proud of you, by the way. You did a good job. Yeah, this is, you're on your way, Jesse. For everyone here is on their way. Seriously, and I hope you learn more about encapsulation and the other two pillars of object-oriented programming. Yeah, you should definitely be able to explain those. That's a question I ask in my interviews now. As a senior engineer, when I interview new engineers, I go, tell me the 5 principles of object-oriented programming and explain what each of them do and what each of them mean. And if they cannot answer that, then I'll say, thank you. Goodbye.
I'll call you.
I'll call you back. So yeah, good job. Hey, do you have any questions about objects? This is really important. This runs almost all the software you guys are using today. Functional and object-oriented programming. None? I think we're at time, man. Dude, great job. That was really hard to do.